Good morning, comrades. This session is to do with arithmetic series using Cuisenaire rods. It's a proper noun, capital C-U-I-S-E-N-A-I-R-E. So we've got numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I asked you to go 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 10, how would you do it? Well, one option is to go 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, etc. But if you had to do that, you could do that for up to 10, that's fine, but if I said count from 1 all the way up to 100, that would be a bit tricky. So one option is to try to turn this from addition into multiplication. What I'm going to do is I'm going to split it into 5. And I'm going to go like that. And so now, if I go 1, 2, 3, 4, 5, plus 6, plus 7, plus 8, it actually turns into an area of width times height. You can go 1, 2, 3, 4, 5 across the bottom. 5 plus 6 is 11 up on that side, and that's the orange is 10, and plus 1 is 11. So it's 11 high, 5 across. So if you want to know how many of these unit volume or unit area there is, the answer is 5 times 11 is 55. So 1 plus 2 plus 3 plus all the way up to 10 is 55. So you can do that by splitting it in half. Might get a little bit trickier if we take one away so that there's an odd number. Yeah, then that method doesn't quite work as well. So what's another option? What you can do is say, hey, I'm going to borrow or imagine, or I'm just going to temporarily double the amount of Cuisenaire rods that I have. And so if you take what we've got there, make an extra copy of it, and then can you make it into a pattern? And the answer is yes, you can. So I've now got double the amount of Cuisenaire rods. So if I can work out the area of that and divide it by 2, then I should also equal that number of 55. So we've got, this time we've got still got 11 up the top. 1, 2, 3, 4 to 10. So 10 times 11. So 11 plus a 0 is 110. Divided by 2. Well, 10 divided by 10 is 10 divided by 2 is 5, and the 100 divided by 2 is 50. So 55. So yeah, 10 times 11 plus 610, but we had to double it to get to that. So now I'm taking away, we have to halve it, so we get to 55. So that's the basic arithmetic series. So how far can we take this? Because that's the most, say, simplest. We're going up by 1 at a time, and we are starting from 1. So what happens if we start from 1, 2, 3, 4, 5? What happens if we start from the yellow one? Well, if we start from the yellow one, then, and we create an imaginary, imaginary triangle opposite. 1, 2, 3, 4, 5, 6. 6 times 10 plus 5. So 6 times 15 is 90. 90 divided by 2 is 45. And 45, if I just go 1 plus 2 is 3, 3 plus 3 is 6, 6 plus, so we took off 10, and we got 45. So I'm just jumping a little bit, but yeah. So this same trick works. Okay, so we don't need to start off at 1. We probably don't need to start off at 10. Okay, well, how about another one? What if we've got starting from 4 and we're only doing even numbers? So I'll take out the 5, the 7 and the 9. So that's brown, blue, orange, brown, green, pink. So this case here, we're starting from 4 and we're going up in 2s. 4 across the bottom, 10 plus 4 is 14, so 4 times 14, 4 times 10 is 40, 4 times 4 is 16, 40 plus 16 is 56. And I'm not going to check that. You're welcome to check it to see if I got it right or wrong. I'll assume that I got it right. So what did I say? 56. So, well, okay. So 56 divided by 2 is 50 divided by 2 is 25. 6 divided by 2 is 3. 25 plus 3 is 28. Have we got 28? 10, 18, 24, 28. Yep, so that works. So we can also do the same trick if we go up in evens from any kind of number. The same will work for odds. You can start and finish at whatever number you like. So that's how we can practically, pictorially do this using Cuisenaire odds. So the thing is, we can kind of like work it out in our heads, but can we generalize it? So we can work out the mathematics in our heads now, but can we generalize it to put it down into a formula? And well, the answer is yes. And before I jump there, I'll just remind you that whenever you do this, if it's arithmetic, it's not 10 times 10, because the triangle is always going to start off and it's either going to be 10 times 11 or 11 times 10. Okay, right, back to the main event. So can we do a formula? Now, ideally you would try to work out the formula yourself, and then I'm going to guess it as well. So to do this trick, we want to do, so we need to divide by 2. That'll be the last thing that you do. Messy. So the formula is going to have a divide by 2 is going to be the last thing that happens. Hey, I don't know, I might as well even show it on screen. How's that? Alright, a formula. So we need to times it by so what's the number that you start off with? It was a 1, and the last number in the series is a 10. So it's so this side here is first number plus last number, so 1 plus 10 is 11. So first number plus last number times how many there are that way. So how many are there that way? There are there's 10, and I'm not too sure of the formula for this, but let's just go. It's going to be something like, if you went from 3 to 10, it will be something like, how many across here? It'll be biggest number minus smallest number. So for example, 10 minus 3 is 7, so there's 7 across there. That's if it's going up by 1, but if it's going up by 2s, then it'll be biggest number minus smallest number divided by the size of the increment. Like, is the size of the increment 2, then there'd be 3.5. 3.5, well, that sounds pretty wacky. 3 minus 10, so let's take out, yeah, it doesn't quite, you can't go up in twos, can you? So that's not a real example, because if you started from 3 and you went up in twos, you'd always end up with an odd number, not 10. So I'll pretend to make it an 11. How's that? Oh, that's too confusing. Let's just go to 9. So 9 minus 3 is 6. That's going up in twos. So it's 9 minus 3 is 6. 6 divided by 2 is 3. So it looks like the answer's, the formula actually needs to be that plus 1. So let's try the same again. This time we'll do it with evens. If I start off from 4 and get rid of the yellow, which is 5 long, the black's at 7 long, the blue that's 9 long. So if I go 10 minus 4, that equals 6, and we're going up in twos, so 6 divided by 2 is 3. So coincidentally it's 3 plus 1. If I start with here, first number is 10 minus 2 is 8. 8 divided by 2 is 4, so it's 4 plus 1. So and if we have an imaginary thing where we started from 0, 0 plus 2, how many is that? So 10 minus 0 is 10, divided by 2 is 5. 1, 2, 3, 4, 5, plus the 0 is 6. So to work it out across the bottom, it's the biggest number minus the smallest number. And then, have I got that right? If I had the biggest number, oh yeah, so the biggest number subtracting the smallest number, that's 9, plus that 1 gives you 10, so it's 10 across the bottom. And how many across the top? It was 10 plus times 11. Okay, so we've done that for doubles. Let's do that for going up in 3. So 10, 7, 4, 1. Does the formula still work? So if I was going to make, generally the triangle is going to look like that. So the answer that we are looking for, so you can either add it up yourself or we'll do it this way. It's 1, so 1 plus 10 is 11, and it's 4 across. It's 44, so there must be 22 there. So the answer we should get to verify a formula is that it's 22. Let's check it out. So we want to go, the generalised formula is the biggest number plus the smallest number, so that's 10 plus 1 is 11. And that way we wanted to do biggest number minus the smallest number divided by the size of the increment. 10 minus 1 is 9, divided by the increment size, it's 3 each time. So 10 minus 1 is 9, divided by 3 equals 3. And then we're going to go 3 plus, we're always adding on 1, so 3 plus 1 is 4. So 4 times 11, the biggest and smallest, equals 44, and then divided by 2, because we had a virtual triangle, is 22. And is that the same answer that I got before? My memory's not so good. That's why it helps. If I understand how a formula works, then I don't need to remember the formula. So that was 4 times 11. Yep, 4 times 11 yep, so that was the same answer that I got. Anyway, so that's a slightly chaotic case of how to use Cuisenaire rods to calculate arithmetic series. Cheers.